Okay, then we're ready for the next presentation. Thomas, please feel free to kick off. And
yeah, you can hear me okay now, can't you?
Yes, we can hear you fine. Thank you. You have your full screen now.
Yeah,
there
perfect. Thank you very much, Stoffer. Yeah, hi, my name's Thomas Grant. I'm a senior geologist working at Cegal. My background is in geology and research geology. I also have a number of years of experience working in data science, so using things like machine learning, Python, and also some database work using SQL. I also have a little bit of experience from the finance industry as well, doing various digitalization projects. Since starting Cegal, I've been working within data science and digitalization projects on geoscience specific data. So one project I want to talk to you about today, we're going to be using a range of different skills. It's going to be covering some machine learning. We're mostly going to be using Python as our core programming language. We're also going to be using a number of services and tools available to us from Azure. This is Microsoft's cloud platform, and this is all we're going to be building a solution that is deployable, potentially deployable through GeoCloud. So I'll just give a little bit of background to what we'll be talking about, just to put some context. So this universe of cloud technology and other sort of programming technologies, frameworks for machine learning and so on, are growing extremely fast. And this is just a very small snapshot of some of the tools that are available to us. But it's a pretty huge crowded market that's expanding extremely rapidly. So when we approach projects, we have experience with quite a few of these different tools, and we have to kind of work out what are the best tools to be using for the project that we want to do. So we're always looking at a technology stack that we either know or used before, or what can we learn and add to our experience. Another thing that's growing exponentially is the amount of data in the world. So all types of data growing extremely fast, and this is kind of, you know, there's a big arms race between what tools you got and the amount of data and what needs what people are wanting to use. So we're going to be focusing on unstructured data. Now, I wanted to find a good quote or a good estimate on how much unstructured data there is in the world, or how much of the world's data is actually unstructured. I settled on this one quote from IBM, although most of the quotes gave fairly similar numbers of 80–90%. It's estimated that around 80% of the world's data is unstructured, but businesses are only able to gain visibility into a small portion of that data. And what we mean by unstructured is this is data that has no regular, not only structure, but it may contain different data types using different file types, and it's presented in a non-systematic way. So how to access that data can be kind of difficult. Sorts of things we're talking about are PDFs, Excel files, PowerPoints, for example. And how can you access the information that's stored within them? So most people can think back to their own working day where they've got file systems, maybe access to potentially thousands, if not tens of thousands of files. And some of these you'll know you may have created yourself or worked on them with other people, but how do you actually gain access to other data that's in this huge file system? How can you actually then use that data? So there could be certain situations where you want to be compiling some data for a given project. So imagine you're a geoscientist, and they're working on this new exciting exploration project. Now, they start collecting some drawbots, and we're going to be focusing mostly on PDFs here. They start getting some draw reports together. Maybe there's some vendor data lying in PDF files that they'd like to collate and be able to use. There could be some research papers, maybe there's some ideas, algorithms, or even some data lying in some research papers that could be useful for their interpretations. And there could even be some internal reports that contain things like previous interpretations, opinions, or data, or some sort of aggregations of data that already existing. So you can see that it quickly piles up to be a lot of information and stored in very different ways. So to pull all this together is a time-consuming task, and we want to make this much simpler. So in comes Project Sputnik. This was an internal project, a summer project last summer. We had an absolutely fantastic student called Bendix Wagner's, who came in working with a software developer here at Cegal called Orlan, as well as myself using the project. So the idea was to have a system for managing PDF documents that can work off the back of OSDU. That's the Open Subservice Data Universe. And how to make the data stored within those PDF files searchable and usable. How can we extract all that information from those PDF files? So early on, a workflow was decided upon where you have your data manager, for example. They upload a PDF document. We're going to keep this box, Project Sputnik, empty for the moment. Something's going to happen to that PDF file to extract that data. We're also going to have to make this box on Sputnik communicate with OSDU to actually store that data in an orderly fashion that you can always access that. Just working off the back of that of OSDU. Our geoscientists, or this could be, just about any profession in any sort of domain, wants to search not only for documents, but within documents for the information that they're trying to put together for their project. So now this empty box needs filling. We need to start saying how we're going to be able to deal with these PDF files and how we're going to extract information from them and then make that information searchable. So we started looking at technology stack. I'll go into a bit more detail of all these things in a moment. But we thought wherever possible, we want to leverage things like open source code or research codes. And we find some really great code through University of Wisconsin that cracks open and fragments PDF files into their various components that we can then start doing some exciting things with. So that's a starting point. We want to do some machine learning. We have to do some image classification and various other things. So we're going to use Keras, a really great deep learning library and framework for programming apps and neural networks. As we all three of us, Bendik, myself, and Tor, all know Python pretty well. It's a common programming language that we can all use together, and we can actually use that in the rest of the technology stack. We're going to use Cegal Data Lab. This is a Cegal managed Jupyter Lab environment where we have all the packages that we need, and it's easy to collaborate between us. And we can develop pretty rapidly a simple user interface for searching all the information extracted from the PDF files. And it allows us to iteratively check that everything's working behind the scenes. We can also develop other user interfaces, but this worked really well, and I'll show that at the end of the talk. We're also able to access some of Azure's services, things like Azure Cognitive Services. This is more out of the box machine learning or artificial intelligence capabilities that we can use. And I'll talk about that a little bit more later. And we're going to be creating a data pipeline here where we're taking the PDF, extracting this information, and storing it somewhere. So we're going to use something called Azure Functions, and this is the scaffolding of our project. It's going to hold everything together. And then we're going to put all this information and data into a database. We chose an Azure Cosmos database, and this is a fantastic type of database, and I'll show you a little bit more about that. So this open source code from the University of Wisconsin, we'll describe it in their own words. And this is automated data extraction and knowledge-based construction from scientific applications. And it enables extraction of fragments, figures, captions, text, and tables from PDF files. Now, they originally envisioned this for specifically scientific publications. As we're dealing with something slightly different, we have to do some more modifications and testing things out. And as they are just returning these fragments like text and figures, then we need to do a bit of modification on top of this to make it more relevant for, say, a geoscientist trying to search this information. So we need to tag things, identify what they are. So on top of this, we built a custom geo-image classifier using transfer learning. So what we took was this preset of weights and architecture of a neural network called MobileNet V2. This was developed by Google a couple of years ago, and it's designed to work on devices with relatively little computing power. So it's a pretty lightweight neural network that has fairly comparable accuracies to some of the bigger, heavier ones like ResNet, for example. What we're able to do is we're just able to take that initial architecture and weights, use that as a feature extraction from the images, and then modify the last couple of layers to output the correct number of classes that we're trying to identify from these images extracted from PDFs. So we identified 14 specific geoclasses, so with things like rows diagrams, maps, thin sections, seismic block diagrams, and so on. And of course, we had to set one class which is no geological relevance. So we had to put in a few extra images that didn't carry any geological relevance, because you could find things in your geo report that have no real geological meaning, but you still need to kind of classify them as something. And just in some of these training images, here's an example that's just a cat. You're not going to find a cat in your draw report, but this is part of that training process. We got pretty good accuracy with this. Now, we don't necessarily want to be designing or building machine learning models in all the cases. Sometimes we can use something that's actually out of the box. So Azure Cognitive Services comes to the rescue here. What this is a comprehensive family of AI services and cognitive APIs to help you build intelligent apps. Cognitive services bring AI within reach of every developer without requiring machine learning expertise. Now, what this means is that it's good to have the machine learning expertise in order to implement them. But it doesn't mean that it means that you don't have to code everything from scratch. You can actually pull something out of the box. And this saves a lot of time for development, because some things, like optical character recognition, you don't want to be programming and training stuff in every situation. Sometimes we just want to be able to use something that's there. And that's what we did in this case. So I won't go into too many details here, but just to give you a flavor, this Azure Cognitive Services is pretty extensive. There's a lot of different services we can use for all kinds of decision making, language processing, computer vision, web searches, and speech recognition. So there's a huge amount in here that we can use if we choose. But we don't need too much of this, but we can use some of these services, and we will be using optical character recognition to extract information from the text that we get from those PDF files. I said before that we need some scaffolding to hold everything together. We're going to have a fairly complicated pipeline, which I'll go into some details of. But there's a really great feature that we can use, and it's called Azure Functions. These are event-driven serverless compute platform that can also solve complex orchestration problems, like the one we're developing. They can operate at scale in the cloud and integrate services using triggers and bindings. So what we're saying here is we can get essentially a script. It's stored in the server, and it can run that script under certain triggers. So let's say we upload a PDF. We can set a function to be able to recognize that PDF. There's a new PDF there in storage, and then we can do something with it. So this is a good framework for us to be able to use. And it has the sort of mentality of you can develop once and deploy multiple times. So it's pretty good. Finally, we need a database in which to store all of our data. So we looked at a couple of databases, and we were quite intrigued to see to implement a Cosmos DB. And what this is Microsoft's globally distributed multi-model database. And when we say multi-model, there are several different APIs in which we can interact with our data. This includes a standard sort of SQL-like API, or for example, we can make a graph database, and we explore both of those models. Cosmos DB enables you to elastically and independently scale throughput and storage across any number of Azure regions worldwide. This is particularly important. Most all companies, or lots of companies, are in fact global, and we want to be able to make that data quickly accessible in multiple regions quite easily. So this is a good database for us to be using. Finally, I said before, we want to make a good user interface, not only to test out iteratively to make sure everything's working, but just a simple way that we can look at this solution or for an end user to be able to interact with this data we're extracting from PDF files. So Cegal Data Labs is a centralized hub for data science and data management, and it helps businesses create quick value by creating small MVPs that can solve problems at hand. So that's exactly what we're trying to do, creating a minimal viable product to be able to have a little search interface for all of this data. So I'm going to go into some details now about the data pipeline that we have built here. So you start off with your data manager. They're going to upload a PDF document to blob storage. We have one of these Azure functions here that's going to say, hey, there's a new PDF file that's being uploaded to blob. We're going to put this in a queue. We've got this new queue of PDF files waiting to be processed. They then get sent to what's essentially GPU PDF processor, and in here lies that University of Wisconsin code that is going to fragment our PDF files. And we need a bit of power and brute force to be able to run this code, and then we can return a bunch of fragments. So this goes back to the blob storage. We have all our extracted pages and documents, and we have a set of metadata that tells us, what PDF file they came from, what page they came from, and what fragment number is. We also have our Geo image classifier up here. We can also plug in one of these Azure cognitive services, optical character recognition or OCR, which is then going to extract those blocks of text into actual meaningful text that we can use in search. Next, we can have a little manifest visualizer where your data manager can just check this process has worked as expected. So it's just a quick QC for the data manager to make sure everything's good. They can then say, okay, this looks good, goes to blob storage, and then we have a little function that can then send that next to you. And this part is still not entirely built, but it just shows that we can easily bolt this on top of OSDU. So now we've got all this metadata and data from our PDF files. We then pass it to another function. And this is going to upload it to our databases in the correct format for those databases. So we've got Cosmos using the SQL model, and we also have the graph model in there as well to find some graph connections between our data files. We can use yet another Azure cognitive service called Azure Search, and this just helps have a good relevant search on top of our databases. Now we can combine these three different searches and databases into what's called a federated search, which and then we can pass this to our user interface, and we can access not only the data from those PDF files, but we can also know which PDF it was, what page number it was, so we make this much easier, searchable, and eventually usable by our user. So it's demo time. I'm just going to exit PowerPoint now and go to my Cegal Labs instance. So this is just shared Jupyter notebooks. It's a managed environment that our data scientists use, and we can have raw code in here, or we can have a very simple user interface that we can here with some boxes that we can make some choices about what we want to search for. So I can just say I'm interested in the Cretaceous. Anywhere I can find the word Cretaceous, and we've processed a handful of PDFs already. And this is GeoCloud. I'm just going to say find Cretaceous in anything, maps, rows, diagrams, thin sections, whatever you like. Let's go and see what we've got. So now in the log, it's searching our database, and it's going to start returning me some pieces of information which are related to Cretaceous. Anyway, we got Cretaceous, base, Cretaceous, top Cretaceous, and we're seeing, a whole bunch of images, pieces of text, maybe even some tables down here at some point. But we've got a whole bunch of information now coming straight to us about the Cretaceous. Well, that's fantastic. We can quickly access the data we want to. Now let's try something maybe a little more specific. Let's look for some permeability data. I want to look specifically for table. Okay, I will actually find some hard data there. I'm going to do a little search now. You can see what a table with some permeability data. It's returning us the fragment ID. So this is the actual ID of that little fragment that's taken from PDF. It's returning us the page ID, so it's page 18. Returning us the PDF itself, so we can always go back to the original PDF. You can see that's correctly identified as a GeoClass as table, and we have the OCR, optical character recognition, actually pulling out the data from this table. So all of that information is now accessible to us in seconds. So going back to my PowerPoint here, I just want to leave you with a few comments. Now, the focus of this is, yes, we've used quite a wide technology stack, but what was really great was this methodology of working and the way that we can utilize our programming skills and geoscience skills to develop specific solutions to real world or business problems. So what we're able to do as a short summary is we leverage some open source code for parsing and cracking PDF documents into separate fragments, things like images, text, and so on. We then adapted this system specifically for the E&P industry by correctly classifying those geo images. So it was very important to make sure that we are looking for the right information. Say, if you really want some seismic images to relate to the Cretaceous, you can search for that. Or be maybe more specific to a specific location, for example. We used a whole range of Azure cloud services to quickly develop a data pipeline and a database to be able to access the data extracted from those PDF files. We were able to use and make a very simple minimal viable product as a user interface. And we used Cegal's own data lab to be able to do this. This is a really great solution for us to collaborate together and work on code as a team. But it also is a pretty viable user interface. It's working pretty well. So yeah, so this is a very highly effective way of working and collaborating together to rapidly develop custom solutions. Now, if you were to think in maybe a more traditional software development perspective, some of this would take maybe years or extremely long time to have all put together, particularly 10, 20 years ago. Being able to do this kind of project would have been massive. But we were able to do this in the space of a month or two with a summer student, a developer, and myself working partially on the project. So it really is an exciting space to be working in and to be able to pull all of this together and make something work. So we've used a range of technology and programming skills in order to do this. So thank you for your attention. Enjoyed talking you through this project. If you have any questions, shoot away or contact us at some point afterwards if you're interested. Thank you.
Thank you very much, Thomas. We had some problems with the sound during the presentation. We will provide. I think there's an internet thing maybe, but nevertheless we will provide a link to that we will share with all of you to YouTube, where you can have some more also better sound during this presentation. But there's a few questions. There's one here: did you create custom skills in Azure CS, and also did you use Azure CS in the PDF processor?
We didn't use those in the actual PDF processing because there was that code already available to us. But I guess we could have drawn upon more of those in this project. It could be that we just used our own image classifier. That's one example we could have maybe done. We didn't code too much on top of those. We used them largely out of the box. which is kind of partly their intention. I think on the short space of this project, that was enough to get us pretty good results. So I think there could be some tweaking in that.
Thank you very much. Any other questions? Feel free to ask them or contact us directly afterwards if you like. We're very happy now to have James Vasquez from Triple Crown Resources presenting for us in 10 minutes. So again, we'll regain we regain 11 a.m. for the next presentation. Again, thank you very much, Thomas, for your presentation.